Welcome. In this talk, I want to look at the famous tension. Einstein used probability all through his work, yet he is also known for the sentence God does not play dice with the universe. Something like that. He wrote in his letter to Max Born. Was he contradicting himself or was he talking about two different kind of probability? That is what we will see. The people quote God does not play dice as if Einstein disliked this probability itself. But in his own paper, he uses statistical mechanics, probability of emission and absorption, and ensemble averages. So the real question is, how exactly did Einstein use probability? And how is that different from the way probability appears in quantum mechanics? Right? So here is one clear written version of that quote. It was written to Max Born on December 4, 1926. Einstein writes, quantum mechanics is certainly imposing, but an inner voice tells me that it is not yet the real thing. The theory says a lot but does not really bring us any closer to the secret of the old one. I, at any rate, am convinced that he does not throw dice. You see, by old one, he means something like nature or God as order. So, already you see, he is not rejecting quantum mechanics as useless. He is saying it is powerful, but not yet the final story about the reality. First, the kind of probability Einstein was very comfortable with. Okay? In classical statistical mechanics, atoms and molecules are assumed to have definite positions and velocities. We simply do not know all of them exactly. So, probability describes our incomplete information over many of these particles. There are so many. And example in this is Brownian motion. A very small grain, it zigzags because of the countless collisions with the molecules. Einstein uses probability distribution to describe this motion, but he still assumes every molecule has a definite trajectory. Here, probability is equal to, you can say, ignorance or complexities, not fundamental randomness. The second example, in his 1905 paper on light quanta, for which he was awarded the Nobel Prize, he proposes that light energy comes in discrete packets, each packet having energy h times the frequency. In the photoelectric effect, the chance that electron is emitted depend on the energy per quantum and how many quanta hit the surface. Again, he is talking about probabilities over many photons and many atoms. Underneath, he still thinks each photon and each electron has a definite physical state. Probability is a tool for describing large numbers of events, not the deep nature of reality. See, third example. This is a famous paper and very insightful paper of 1916 and 1917 on the quantum theory of radiation. He considers atoms with a discrete energy levels in the radiation field. He introduces his two famous coefficients A, probability per unit time for spontaneous emission, and B, capital B, probability per unit time for stimulated emission or absorption. Using this transition probabilities an idea of detailed balance at equilibrium, he derives Planck's radiation law without Planck's original curve fitting idea. See, this is a masterpiece giving the, I mean, here he is directly giving what the nature is doing in reality. That's why it's a depthful paper. Again, here these are ensemble probabilities over many atoms and photons. Einstein suspects there is a deeper law behind them, but we don't know it yet. So, three clear cases where Einstein is happy to use probability. Now, compare with the standard quantum mechanics scene. The wave function psi evolves deterministically in time according to Schrodinger's equation. But when you actually measure something, the theory tells you only probabilities of different outcomes. The Born rule, Max Born rule says the squared magnitude of psi gives the probability distribution of the result. Now, in many situations, before measurement, the situation is described as a superposition, not as having a single definite value. In the usual Copenhagen type reading, it's like Bohr, Heisenberg, and all those. It is not meaningful to say the particle had a definite position or a value before you measured. Only the probabilities are considered real. See, uh, this is the point where Einstein becomes uncomfortable. His problem is never or not there is a probability in a calculation. He has been using probabilities since his very early work. His problem is this claim that there is no deeper definite reality underneath the probabilities. That randomness is a fundamental. What? That Copenhagen reading essentially means randomness is a fundamental. And third is that probability is the final answer, not the shortcut. Now, Einstein's intuition is that the universe has an underlying deterministic structure, and that quantum mechanics is very successful but incomplete description of it. This I would like to quote in 1935 with Podolsky and Rosen. This paper was also very famous. They imagined two particles in an entangled state. If you measure one, you can predict the result of the other with certainty, even when they are far apart. Now, this EPR argues if you can predict the value with certainty without disturbing the second system, then that value must correspond to an the element of reality, right? That's what it means. So, therefore, they conclude either quantum mechanics is incomplete or it does not include all elements of reality, or the world must be non-local in a very strange way. Again, Einstein's hope is maybe there are hidden variables or deeper state behind the wave function. So the quantum probabilities are like statistical mechanics, just the reflection of our ignorance. The debate is very here. We'll see. Now let's make the distinction very clear. First, statistical or epistemic probability. We assume each system has a definite state. We don't know exact values. So we use probability distributions over many possible microstates. This is the kind of probability in thermodynamics, Brownian motion, radiation paper. Here probability is equal to, we can say, ignorance or huge complexity simply. Second, fundamental or ontic probability. Even in principle, the system does not have a definite value before measurement. The world itself is irreducibly random at that level. Probability is not shortcut. It is the final description. See, this is how many people interpret quantum mechanics. Einstein accepts and uses the first kind of probability. Probability as statistics of incomplete knowledge, sitting on top of an assumed finite reality or structure. He rejects the second kind, where the idea that reality itself is just a pure dice game with no deeper law. See, the idea that there is nothing more real under the born probabilities. So when he says he does not throw dice, he means the underlying order of nature should be lawful, not random. Fundamentally, in the square thing, it is fundamentally random. So he is not saying never use probability in physics. He is saying probability should not be the whole story. Now, in popular stories, you often hear Einstein did not like probability. More accurate is Einstein did not claim that probability is the final reality. He was willing to use probability very strongly in his work. For him, it was always description of what we don't fully know. This is again and again repeatedly used here, not the description of universe that has no definite state under it. As I said, even today, the foundation of quantum mechanics, the debate is still alive. Some interpretation of quantum mechanics say that quantum randomness is truly fundamental. Now, others propose that hidden variables, some pilot wave theories, many world interpretations, or other deeper structures, even many mathematicians are working on this. So Einstein's view was quantum mechanics is practically extremely successful, but conceptually it might not be the real thing yet. The purpose of this talk is simply when you hear God does not play dice, you understand that Einstein's dispute was not with the probability as a tool, but with a particular claim about the nature of reality. See, I feel that certain great minds are in tune with the nature, just like Ramanuj. He used to say that if there is no word of God in the equation, it has no value. So, so I feel there is some tuning with the nature of such minds. Thank you for watching.